Welcome to all of you. So today we have seen the closure relation. Okay. So as the yesterday's lecture, we have to seen about the how to draw the Hasse diagram. Okay, and how to write the matrix from the partition also. Okay. So this is the very simple and closure relation also be the one of the part of the relations. Okay. So closure relation. So what is the closure relation? So transitive closure of the R by the Warshall's algorithm. Okay, so this is very important algorithm, that is the Warshall's algorithm. So we directly solve the example how we can use the Warshall's algorithm to find out the solution. Okay, so example, let's A is equal to 1, 2, 3, 4 and R is equal to 1, 2, 2, 1, 2, 3, 3, 4. You have to find the transitive closure by using the Warshall's algorithm. Okay, so what you have to require? So firstly you have to require to write the matrix. Okay, so for the matrix, so A is equal to 1, 2, 3, 4. Right here 1, 2, 3, 4 and 1, 2, 3, 4. Okay, and whatever the relation 1, 2 now, so go to your first row and second column and write here 1. Okay, then go your second row and first column. Go your second row and first column. Write here 1. Okay, write here 1. There 2, 3. Your second row, third column. Write here 1. Then 3, 4. Go to your third row and fourth column. Okay, that is ones, otherwise all are the zeros. Okay, so you can be write easily matrix by using the relation. Okay, by using the relation. Then step first. Okay, then step first, whatever first step is your matrix representation. Okay, first step is your matrix representation from the relation. Okay, from the relation you can write matrix easily. Okay, you can write matrix easily. Then step second, whatever k is equal to 1. Okay, k is equal to 1. So this is your very important, what k is equal to 1. Then go to your first column. Okay, go to your first column. Here is, okay, you can see here now, here is whatever, here is, go to your first column and see here is 1. Okay, 1 from this particular column, first column. So you can see here in second row you can find out here 1. Okay, you can find out here 1 easily. Okay, then what is the another step? So row 2, row of 2 contain 1. Okay, in column number 1. So k is equal to 1. Okay, k is equal to 1. So what they say that we have to find 1 in the second row. Okay, of first column. Okay, so what you have to require, you have to require to modify your second row. Okay, modify your second row by using the row 1. Okay, by using the row 1, because k is equal to 1 now, because k is equal to 1. So row 1, simply write your first second row. Okay, that is 0 1 1 0. Okay, 1 0 1 0. Okay, 1 0 1 0. And what is your row 1? 0 1 0 0. Okay, why row 1 is used? Because k is equal to 1. Okay, listen here. Okay, what k is equal to 1, that's why you have to use here row 1. Okay, and using ORing operation. Okay, using ORing operation to 1 or 0 is 1, 0 or 1 is 1, 1 or 0 is 1, and 0 or 0 is 0. Okay, so what is the another step? Another step is whatever the modification is only the second row. Okay, modification is only in the second row. So what you have to require? So you have to require to change only the second row. Okay, change only the second row. Listen carefully here, this is very important. Okay, change only second row. Okay, what is here? Change only second row. So you can see here 1 1 1 0, 1 1 1 0. Okay, right, 1 1 1 0, but all row except then second row you can write as it is. Okay, you can write as it is. So this is your row, this is your value. Then k is equal to 2. Then go toward your second column and find it. Where is 1? Okay, where is 1? So where you can find out the one? So your first row you can find out the one. Okay, your first row you can find out the one. So you have to require the modification in row 1. Okay, modification in row 1. So row 1 contain 1 in column 2. So k is equal to 2. So for the modification of the row 1 you have to require row 2. Okay, why row 2 is required? Because the value of k is equal to 2. Okay, because the value of k is equal to 2, so you use for the modification of row 1 is row 2. Okay, so by the ORing operation between the or 0 or 1 is 1, 1 or 1 is 1, 0 or 1 is 1, and 0 or 0 is 1. So here is modification is only the first row. Okay, only the first row. So modified row you can, so this is modified row you can write here. Okay, modified row you can write here because this is modified row, and all the row as per your above matrix. Okay, all the row as per your above matrix except first row. Okay, except first row. Then step 4, what? K is equal to 3. So why k is equal to 3? Because here is k is equal to 3. So go toward your third column and find out where is 1. Okay, where is 1? So row 1 and row 2 contain 1. Okay, row 1 and row 2 contain 1 in column 3. Okay, so k is equal to 3. So what is the operation? So the you have to require modification in row 1 and row 2. So what is the modification in row 1? So row 1 or row 3. So why it is row 3? Because k is equal to 3. Okay, because k is equal to 3 simply, and row 2 is equal to row 2 or row 3. Why row 3 is here? Because k is equal to 3 na. So for the operation, first operation is the modification in first row. Okay, modification in first row. So ORing operation between row 1 and row 3, because the value of k is equal to 3. Okay, so 1 or 0 it is 1, 1 or 0 it is 1, 1 or 0 it is 1, and 0 or 1 it is also with the 1. Okay, so this is first modified row. Then another one, row 2. Row 2 is the 1 1 1 0, and this is row 3. So this is ORing operation between row 1 and row 3. Okay, 1 or 0 that is 1, 1 or 0 that is 1, 1 or 0 that is 1, and 0 or 1 that is also be the 1. Okay, then next step you have to write these two modified row in the matrix. Okay, which modified row? Your row 1 and row 2. Okay, so here right here row 1 and row 2, and 3 and 4th row right as per your above matrix. Okay, as per your above matrix simply. Okay, uh, then k is equal to 4. Okay, what? K is equal to 4. Simply go toward your fourth column. Okay, and find out where is 1. Okay, find out where is 1. But what we can say that in fifth 5 no effect. Okay, no effect, because as row 4 contain only zeros. Okay, only contain 0. So they say that therefore the transitive closure is 1 1 1 1 1 1 1 and 0 0 0 1 0 0 0 0. Okay, because here is only the 0 in row 4th. Okay, this is your first example of the transitive closure. Okay, this is very simple and you can get out of marks in this particular example. Okay, then another one. Second example, what? Find the transitive closure of R by Warshall's algorithm. Okay, so A is equal to 1, 2, 3, 4, 5, 6. Here is 6 into 6 matrix. Okay, so this is the relation. Okay, this is the relation x minus y is equal to 2. So what is the condition? This condition is x minus, this is the relation now, x minus y is equal to 2. Okay, x minus y is equal to 2. So the relations are, okay, 1 3. Okay, 1 minus 3 is equal to minus 2. Through 3 minus 1 is also equal to 2. 2 minus 4 is also equal to minus 2. 4 minus 2 is also equal to 2, because here is the mod na, here is the mod, so minus sign is not negligible. Okay, so it is negligible. So 3 minus 5 is also be the 2, 5 minus 3 is also be the 2, 4 minus 6 is also be the 2. So this is the solution. Okay, so this is particular set, you can write your matrix. Okay, you can write your matrix. So go to your first row and third column, first row and third column, here is the 1. Then 3 1, go to your third row and first column. Okay, go to your third row and first column and write 1. Then 2 4, go to your second row and fourth column, there is 1. Okay, then 4 2, go to your fourth row and second column and write here 1. Okay, right here 1. Then 3 5, go to your third row and fifth column and write here 1. Okay, right here 1. And 4 6, go to your fourth row and sixth column. Okay, fourth row and sixth column and write 1 and 6 comma 4. Okay, go to your sixth row and fourth columm. Okay, and write here 1. So this is the simple step to write the matrix. Okay, and in first step, so what, k is equal to 1 na, k is equal to 1. So find out where is 1 in first column. Okay, so you can find out here in third row. Okay, third row here is 1. Okay, in third row here is 1. So you have to require the modification in third row. Okay, modification in third row, but the modification using first row operation. Why it is first row? Because k is equal to 1. Okay, k is equal to 1. So row 3 or row 1. Okay, this is the ORing operation between two row. So why row 3 is here? Because 1 in contain in first row whenever the value of k is equal to 1. Okay, whenever the value of k is equal to 1, so row 3 is required the modification. Okay, and row 1 is here. Why row 1 is here? Because k is equal to 1. Okay, k is equal to 1. So ORing operation between these two row, we can get this answer, 0 or 1 or 0, that is 1, 0 or 0, that is 1, 0 or 1, that is 1, 0 or 0, that is 0, 1 or 0, that is 1, and 0 or 0, that is 0. Okay, then this is the modified row. This modified row only, this row is right in the third row. Okay, 0 1 0 1 0 1, and all rows are right as per your above matrix. Okay, all rows are right as per your above matrix, but only right third row. Okay, this is your third row as per this operation. Okay, as per this operation, and all row written as per above. Okay, then k is equal to 2. Okay, k is equal to 2. So what you have to require, go to your second column and find out where is 1. Okay, find out where is 1. So you can find here 4. Okay, you can find your fourth row. Okay, this is fourth row na. This is fourth row. So you have to require modification in fourth row. Okay, modification in fourth row. So fourth row is equal to row 4 or row 3. Okay, so why it is row 2? Because here is k is equal to 2. Okay, k is equal to 2. That's why here is row 2. So the modification or in operation between row 4 and row 2. Okay, modification operation between row 4 and row 2. Why it is row 4? Because you can find out 1 in row 4. And why it is row 2? Because the value of k is equal to 2. Okay, then the ORing operation between these two row, we have to require the modification in row 4. Okay, 0 or 0, that is 0, 1 or 0, that is 1, 0 or 0, that is 0, 1, 0 or 1, that is 1, 0 or 0, that is 0, and 1 or 0, that is 1. Okay, so this is the modified row 4. Okay, this is the modified row 4. So you can write next matrix. Okay, this is row uh, fourth row, and all the rows write as per your above matrix. Okay, all the rows write your above matrix, but only modification in fourth row. Okay, modification in fourth row. Then what we have to say, you have to say that k is equal to 3. Okay, here is the value of k is equal to 3. So what, go to your third column. Okay, go to your third column and find out where is 1. Okay, so you can find out here row first and row 5 having 1. Okay, row first and row 5 having 1. So you have to require the modification in first row and fifth row. Okay, modification in first row and fifth row by using the row 3. Okay, by using the row 3. So these are the two operation. Row 1 is equal to row 1 or row 3. Why it is row 1? Because here is 1. And why it is row 3? Because k is equal to 3. Okay, row 5 is equal to row 5 or row 3. Why it is row 5? Because here is 1. And why it is row 3? Because value of k is equal to 3. Okay, so the modification in row 1. So this is the operation between row 1 and row 3. Okay, so 0 or 1, that is 1, 0 or 0, that is 0, 1 or 1, that is 1, 0 or 0, that is 0, 0 or 1, that is 1, and 0 or 0, that is 0. Okay, then another what, then operation between row 5 or row 3. Okay, because here is the modification in row 5. Okay, modification in row 5. So row 5 or row 3. Okay, so 0 0. So these are the row 5 now. Row 5 is 0 0 1 and triple 0, 0 0 1 and triple 0. And row 3, what is your row 3? 1 0 1 0 1 0 1 0 1 0 1 0. Okay, this is your row 3. Okay, then 0 or 1. Okay, 0 or 1 is 1. Okay, then 0 or 0, that is 0, 1 or 1, that is 1, 0 or 0, that is 0, 0 or 1, that is 1, and 0 or 0, that is 0. Okay, so this is the one of the example. Okay, get it now? So in next matrix, what you have to require, you have to require to write these rows, these modified rows, these modifies row number 1 and row number 5 in below matrix. Okay, so this is the modified rows as per these operation. Okay, as per this operation 101010. Okay, so here is 101010. Okay, get it now? And 101010. So fifth row is also be the 101010. Okay, and all the rows write as per your above matrix. Okay, all the rows write your above matrix. Then k is equal to 4. Okay, k is equal to 4. So find out where is 1. Okay, so you can find out row second and row 6 having 1. Okay, row second and row 6 having 1. So we have to require modification between row 6 and row 2. Okay, so this is the operation. First operation is row 2, modification in row 2. Row 2 is equal to row 2 or row 4. Why it is row 4? Because the value of k is equal to 4. Okay, because the value of k is equal to 4. Then row 6. Okay, modification in row 6. Row 6 or row 3. Row 4. Why it is 4? K is equal to 4. And why it is 6? Because here is 1. Okay, here is 1. So we have to require to modify these two rows. Okay, so modification in two rows we can get a second modification rows the 010101. Okay, so this is second modified row, and this is sixth modified row. What? 010101, that is the same rows. Okay, 010101. So first second row 010101, and sixth also 010101. Okay, and all the rows except 2 and 6 written as per the above matrix. Okay, as per the above matrix. Then keep k is equal to 5. Okay, k is equal to 5, and find out where is 1. Okay, so you can be find out 1 here. Okay, where first row and third row. So you have to require modification in first row and third row. Okay, so row 1. So why it is row 1? Because here is 1 now. So you can visit k5. Okay, this is k5 and here is 1. So you have to require modification in row modification in row first. Okay, so row 1 or row 5, this is the operation, and row 3 or row 5. Okay, row 3 or row 5. So this is the modified first row, and this is the modified your uh, third row. Okay, so they say that no any effect on row 1 and row 3. Why no any effect? Because row 1 and row 5 is the same element, and row 3 and row 5 is also be the same element. Here you can see here 1100 1100 so ORing operation you can get same answer. Okay, and here is also be the ORing operation, you can get same answer. Okay, no any effect on row 1 and 3 because all the rows are the same. Okay, all the rows are same. Then go toward the your sixth step. Okay, that is k is equal to 6, but here is no modification, so you can write all rows as it is. Okay, all row as it is. Then k6. Okay, so you can find out where is 1. Okay, so in k6, so your second row and fourth row also be the 1. Okay, also be the 1. So modified rows are row 2 and row 4. Okay, modified rows are row 2 and row 4. So in row 2 operation, row 2 or row 6. Why it is row 6? Because k is equal to 6. Okay, because k is equal to 6, and row 4 or row 6. Okay, so why it is row 6? K is 6, and why it is 4? Because here is 1. Okay, here is 1. So you can write the operation. Here is also you can see here 001110011001. Okay, here is also be the no effect of
any row on row 2 and row 4, because row 2, row 4 and row 6 have the same element. Okay, row 2, row 4 and row 6 have some element, so here is no any effect. Okay, so the transitive closure is what? 1 0 1 0 1 0 0 1 0 1 0 1 1 0 1 0 1 0 0 1 0 1 0 1. Okay, 1 0 1 0 1 0 and 0 1 0 1 0 1. Okay, so as per this, okay, as per this matrix, this is your transitive closure. Okay, get it now? So this is the very simple example of the transitive closure. Okay, this is another example. Okay, another example of transitive closure. Okay, so what is the another example of transitive closure? So let a is equal to what? 1 2 3 4. Okay, is equal to 1 2 3 4, and let r is equal to r and s be the relation on a, to use the Washer's algorithm to complete the transitive closure. Okay, so how you can complete the transitive closure? R union yes. Okay, here is the union now. Here is the union, so you can write union matrix. Okay, so this is the separate matrix. Okay, 0 0 1 1. Okay, only you have to require, here is 1 na, so you can write here 1 also. Here is 1, you can write here 1 also. Here is also be 1. This is 1, you can write here is 1. This is 0 0 0 0. So you have to require the write the combined matrix. Okay, or you can say that union matrix, R union yes. Okay, so this is the R union yes matrix. Okay, this is R union yes matrix, means the you can combine these two matrix into one matrix. Okay, you can combine two matrix to one matrix. Here is 1 1, so this is 1, you can write here 1 also in R union yes. Then this is 0 0, so this is 0 1 0. Okay, second row, this is 1, so you can write here 1 in R union yes. Okay, then 0 0, here is 0, so you can write here 1 in R union yes. Okay, so you can get these types of matrix. Okay, this type of matrix, that is 1 1 0 1 0 1 0 0 0 1 1 0 and 0 triple 1. Okay, so this is the, you can get the union matrix. Okay, you can get the union matrix simply. Okay, you can get the union matrix simply. Then step 1, so what is they say? K is equal to 1. Okay, so this is the step 1. K is equal to 1, so find out where is 1. So you can find out first row also be the 1. Okay, so it will no effect. Why it is no effect? Because K is also be 1 and 1 is also be contained in first row. Okay, so the modification operation between row 1 and row 1. Okay, row 1 or row 1, this is the arithmetic operation. Okay, why it is row 1? Because here is 1 now, here is 1, so you can use here 1. And why it is row 1? Because the value of k is 1. Okay, the value of k is 1, so this is the modified row. But here is no effect, because uh, row 1 modification, row 1 is the row 1 or row 1. Okay, then another one, k2. Okay, k is equal to 2, so find out where is 1. Okay, find out where is 1. So you can find out here row 1 also having 1, row 2 also having 1, row 3 also having 1, and row 4 also having 1. So here is 4 operation at the happen. Okay, 4 operation at the happen. Why? Because this is k is equal to 2 now, and where is 1? All the matrix having 1. Okay, so the first operation what? Row 1. Okay, this is the modification of row 1, so the ORing operation between row 1 and row 2. Okay, so row 1, you can write simply this operation is here 1101. Okay, row 2. So row 2 in 0100. Okay, 0100. So the ORing operation 1 or 0, that is 1, 1 or 1, that is 1, 0 or 0, that is 0, 1 or 0, that is 1. Okay, so this is the first row, this is the first modified row. Okay, this is first modified row. Then another one, row 2. So write row 2 operation 0100. Okay, 0100 and row 2 whatever. So here is also be the no effect, because these two elements of this two, this is operation on the same row. Okay, operation on the same row, so here is the no effect. Then another operation, that is row 3 and row 2. Okay, row 3 or row 2. So here is 3, third row. You can write this row. Okay, 0, 1, 1, 0. Okay, 0, 1, 0, 0, 1, 1, 0. And row 2 is 0, 1, 0, 0. Okay, 0, 0, 1, 1, 1, 1, 1, 0, 1, 0, 0, 0. So you can get the modified row is what? 0, 1, 1, 0. Okay, so this is the modified row. Then another one, row 4. Okay, no, row 4 0 1 1 1. Okay, row 2 is 0 1 1 0 1 0 0. Okay, or you can get 1 1 1. So it will no effect on row 1 2 3 4 when k is equal to 2. Okay, then we move toward the why it is no effect, because you cannot be any no any changes now, no any changes. Row 1. Okay, here is row 2. Here you can get the 0 1 1 0 1 as per. So this is, these two are the same now, row 1 and modified row 1 is same. Here is also row 2 and modified row 2 is same. Then row 3 or modified row 3 is the same, and row 4 and modified row 4 is also be the same. So what they say, it will no effect on row 1 2 3 and 4 when k is equal to 2. Okay, then step 3. So what is your step 3? So k is equal to 3. Okay, k is equal to 3. So find out where is 1. So you can find out row number 3rd and row number 4th having 1. Okay, so you have required the modification in 3rd row and 4th row. Okay, so the operation is row throw. Why it is row throw? Because k is equal to 3. Okay, because k is equal to 3. So row 3 and row 3 no any change. Okay, and row 4 and row 3. So 0 100 1 1 0 1 1 0. Okay, and you can get the modified row 3 is 0 triple 1. So you can see here row 4 and modified row 4 is also be the same. So they say that it will no effect on row 3 and row 4 when k is equal to 3. Okay, when k is equal to 3. Then another one, what? Step 4. Step 4 what? K is equal to 4. Okay, k is equal to 4. Then you can find out row 1 and row 4. Okay, row 1 and row 4 having 1 na. Row 1 and row 4 having 1. So modification in row 1 and row 4. So row 1 is equal to row 1 or row 4. Why it is row 4? Because k is equal to 4. And why it is row 1? Because 1 is here in first row. Okay, 1 in the first row. So this is the first operation, row 1 or row 4. Okay, so 1 1 0 1 and 0 triple 1. So you can get the modified first row is 1 1 1 1. Okay, you can get the modified first row is 1 1 1 1. Then row 4, row 4 is equal to 0 triple 1. and row 4, this is the same. In this particular operation no any effect, okay, because row 4 and modified row 4 is same, okay. So write your this particular modified row 1 is here, okay, modified row 1 is here, and write all the rows as per the above matrix, okay, as per the above matrix. So this is the example of the transitive closure, okay. So this is also be the very simple topic, okay, this is the very simple topic of the this particular unit, okay. Then we move toward the another example, okay, another example, that is the find the transitive closure of relation are on is equal to 1 2 3 4 defined by, okay, here is they gives you relation, okay, they gives you relation 1 comma 2 1 comma 3 1 comma 4 2 comma 1 2 comma 3 3 comma 4 3 comma 2 4 comma 2 and 4 comma 3, okay, they gives you particular relation, okay, and from the relation you have to require to write the matrix, okay. So how you can be write the matrix by using this particular relation, okay. So 1 2 go your first row and second column, here this is 1 2 1 3 go your first row and third column, this is your 1 3 1 4 go to your first row and fourth column, here is 1, then 2 1 second row first column, then 2 3 for second row third column, 3 4 so 3 4 say third row fourth column, 3 2 third row second column, 4 2 uh, fourth row second column, 4 3 uh, fourth row third column, okay. So this is you can write matrix by using the relation, okay, simply you can write the matrix by using the relation, okay, get it now. So this is the very simple, you can write it easily, okay, you can write it easily. Then another first step is k is equal to 1, okay, k is equal to 1. So this is the solution step, okay, what k is equal to 1. So go to your first row and find out where is 1, okay. So you can find uh, second row where is 1 na, where is 1 in first column, okay, where is 1 in first column. So modification in row second, okay, modification in row second. So operation of row 1 or row 2 or row 1, why it is row 2, because this is 1 here, okay, this one here, and why it is row 1, the value of k is equal to 1, okay, the value of k is equal to 1. So the operation between row 2 and row 1. So you can get modified row 2. Okay, modified row 2. So you can simply write here your modified row 2 and all row as per above matrix. Okay, all row as per above matrix. Then k is equal to 2. Okay, k is equal to 2. So what they say, every row contain 1 in the column 2, okay. So therefore every element will be become 1, okay. So what they say that here is all the in column 2 all the element are the 1 na. So here is modification in all row, okay, modification in all row, and they say that here is in row all the elements are the 1, so they can say that all the matrix having 1, okay, modified by the 1. So this is the transitive closure, okay, this is the transitive closure 1 1 1 1 1 1 1 1 1 1 1 1 and 1 1 1 1, okay. So this is the transitive closure. Why it is transitive? Because here is the operation ORing operation of all rows na, all rows, because here is the in second column every element is the 1 na, every element is 1. So we have required the modifying all rows, okay, modifying all rows, but in row second having the all elements are the 1, okay, all elements are the one, that why we can get uh, all elements are the one. Okay, every element will one, so we can write the transitive closure is 1 1 1 1 1 1 1. Third row is also be the 1 1 1 1, and last row is also be the 1 1 1 1. Okay, so this is the matrix. Okay, this is the matrix. Then okay, this is the example of the transitive closure. Okay, transitive closure is the end. Okay, so we see the next chapter at the next lecture. Okay, thank you all of you.